Now we're going to start looking at our individual periodic trends. The first one we're going to look at is what's called atomic radius. Atomic radius is literally the radius of the atom. Specifically, it's measured in, if we were looking at solid atoms that are right next to each other, if I figured out half the distance between adjacent nuclei, that was what they term the atomic radius. When we are trying to decide, there's two things we're going to look at. Well, first we're going to find them on the periodic table, and then we're going to decide, are they in the same period? Are they in the same group? And if they're in the same group, we address it differently than if they're in the same period. So if I take a look at beryllium and fluorine, both of them are in the second row. And since they're both in the second row, I know they each have two shells of electrons. If I look more carefully at their atomic structure, I'll see that beryllium has 4 protons. 2 electrons in the first shell and 2 electrons in the second shell. Fluorine has 9 protons with 2 electrons and 7 electrons. As we talked about in the last video, what's different about these two atoms is the effective nuclear charge. Again, since fluorine has a higher effective nuclear charge, it's going to pull more strongly on its electrons and pull them closer, making it smaller. So the one with the higher effective nuclear charge is smaller. Another way to think of it is as I go across the row, going from left to right, they're going to go from small or large to small, or I can think of it as if I go from right to left across the row, they go from the smallest here to the largest here. Another thing I can ask you to compare is if the two are in the same group. So if I consider lithium and potassium, since they're in the same group, they have the same effective nuclear charge. So that's not going to explain any difference between the two of them. However, if I look at their electron arrangements, I'm going to find that lithium has 2 shells of electrons, whereas potassium has 1, 2, 3, 4 shells of electrons. So potassium is going to be bigger. Because it has more occupied shells of electrons. So if I were summarizing this trend, on the periodic table, as you go this way, things get larger. And as you go this way, things get larger on the periodic table. Therefore, your smallest element's going to be helium, and your largest element's going to be francium. If you are looking for explanations why, how you explain it depends on whether they're in the same row or the same group. Let's take a look at a couple of samples. So my first one here, which has a larger radius, sorry, this should definitely say barium, beryllium or barium. If you locate beryllium and barium on the periodic table, you'll find that they're in the same column, but barium is further down that second column. So barium has more shells of electrons and it is larger. For sodium and aluminum, you're going to find that they're in the same row. So they have the same number of occupied shells of electrons. Therefore, the difference is going to be based on the effective nuclear charge. Al has a higher effective nuclear charge. And when it has a higher effective nuclear charge, it can pull more strongly on the protons, making it smaller. And if the question's asking me to choose the larger one, it'll be sodium. And indeed, on the periodic table, sodium is in the same row, but to the left of the aluminum. which follows this trend of being further to the left. We are going to ask you to decide which one's larger and to explain which one's larger. In the last two examples, I went through the explanation as I was deciding, but I want to remind you that if I just simply need to decide which one's bigger, it's really easy as long as I can find them on the periodic table, because I know they get larger as we go to the left and then down. So if I'm comparing helium and hydrogen, the one that's further closest to this corner of the periodic table is going to be bigger, therefore helium. For my second comparison, I want to compare fluorine and oxygen. Oxygen is closer to that corner, so it will be larger. For my third comparison, I'm asked to compare copper and barium. Barium is closer to that corner, so it is larger.